Did this yesterday. I remember a function f of x just replaces y. Okay, so when you have function notation, so f of x, yeah, just going back over it again. So if you have function notation, every x will be replaced by whatever's in the parentheses. So in this case, it happens to be 2. We did this one yesterday. So instead of 4x, it's negative 4 times 2 plus 7, which would be negative 8 plus 7, which gave us the negative 1. And here, instead of x, it's going to be negative 3. And we've got this plus 1 that gets tacked on to the end. So it's going to be negative 4 times negative 3 plus 7. And then we tack on that plus 1 that just hung out over here. So that's going to give me 12 plus 8, which will be 20. Okay. We'll just do them again. X is replaced by 1. So I get 2 minus 3, so that's negative 1.
Why is f equals 2? Why is f equals 2? Like, where does that come from?
Here?
No, the first one.
This one up here?
Yeah.
This is just given to you. This will be given. It's whatever problem they give you. That's just telling you that's the function that they want you to evaluate. And so what this is a line. And these are various points. These are points on the line. And then when this kind of stuff happens, this is if I take the line and I manipulate it, where would I be? So this is like, if I take the point on the line, but then I subtract it from 6, where is that? Or if I take these 2 points on the line and I add them together, where's that kind of thing? So we're just, anytime you'll be given this, that's like, you don't have to come up with this. You don't have to derive this or find it. It's going to be given to you, and then you'll be.
F is a 2 and the 1 is the x. So you just.
Yeah, f of x. This is basically saying y equals 2x minus 3, but we replace the y with f of x, and all this tells us is this is a function for sure. 100% it's a function. You can't have f of x if it's not a function. It would just have to be a y. So, and then this notation tells us, like, if f of x is 2x minus 3 and we want to find f of 1, you take the x out and you put the 1 in. Here I take the x out and I put the negative 2 in. So,
wait, so does that mean they're all functions?
Yeah, they're all functions. So f of x was 2x minus 3, right? So for f of negative 2, I take x out and I put negative 2 in. So that becomes 2 times negative 2 minus 3. Does that help? So this becomes then negative 4 minus 3, so it's negative 7. When this is occurring, I've got 6 minus f of 5, so I do 6 minus, and then f of 5, I take the x out and I put the 5 in, so that's 2 times 5 minus 3. So that's this part. So this becomes 6 minus 10 minus 3, which is 6 minus 7, which is negative 1. So this 6 minus part, that's just this part here. So it's outside of the f of x, and so we just like tack it on. It's hanging out, and we just put it there because it was already there. But again, that's not something you come up with. It's already there. So you just copy what's already there, and then you replace this with whatever's up here, but with the 5 instead of the x. Here I have f of negative 1 plus f of 2. Okay, so I'm going to do, I'll say this one is black and this one's blue, just to help. Okay, f of negative 1. This plus was already there. And then f of 2. Okay, so then 2 times negative 1 is negative 2 minus 3 plus 2 times 2 is 4 minus 3. And I can break this up however I want to. Like I can do negative 2 minus 3 and then add 4 and then subtract 3, or I can put these two together and these two together and then add them, however you want to at that point. I'm just going to do that because it seems easiest. And then negative 5 plus 1 is negative 4. This is a function that is not a straight line. And so that means the x's have exponents. Now on that homework where you had the x squared plus y squared, that's not a function because the y also had an exponent. To be a function, only the x can have the exponent, not the y. Does that make sense? Because these are curves, and a squared looks like this, and a cube looks like that, and a fourth looks like that, and a fifth looks like that, but you still pass the vertical line test. If I start throwing y squareds in there, I get circles and ellipses, and so then it doesn't pass the function test. So x has exponents, y's don't have exponents. But we're using function notation, so now we talked about f of x. F of x is function notation, so is h of t. We can have f of x, you can have g of x, you can have h of x, you can have h of t, you could have f of a, it doesn't matter. All this is saying is that these are functions of this variable. And it's usually f, g, or h that are the letters used. I'm not 100% certain why, except maybe they come in order. Okay, so in the same way as you did with f of x, if h of t, so h of t is this whole thing, okay, I want to find out what is h of 4. I take both of these t's out and I put a 4 in. So I have negative 16 times 4 squared plus 68 times 4 plus 2. Okay, so that's negative 16 times 16 plus 68 times 4, and I am feeling incredibly lazy. Oh, shoot, what do you do? So I'm going to pull out the calculator. Okay, and so I've got 68 times 4 is 272. And then 16 times 16, I believe, is 256, but let me just double check. Yep, 256. So I have negative 256 plus 274. So 18. Okay, so we're replacing both t's with 4 in this example. Now here, this is kind of a unique case. You're going to replace t with whatever is in the parenthesis. So in this case, replace t with g. And then this 2 on the outside tells me to multiply the whole thing by 2. Okay, So the setup on that is going to be 2. And then instead of t squared, I have g squared. And instead of t, I have g, and then 2. So I replaced the t's with g's, and then I have to multiply the whole thing by 2. Negative. Okay.
Then you do the two things numbers.
Hmm?
You do the two things numbers. The G's, combine them together, right?
No, because this is a g squared and this is a regular g, so I can't put them together. I could only put them together if they were both g. That's how you read this. Okay, these, just replace it with a 4, just replace it with a negative 5. This one, replace it with an x. It's already an x.
So replace it with W.
Okay, we'll use w, why not? We'll replace it with a w. W.
Nice. Are you wavy line?
We can replace it with anything, really. We'll replace it with a w, and then we'll multiply it by 3, and then we'll add 2 to it. And here we're going to replace it with a negative 3, and replace it with a 1, and subtract them. Okay? So, replacing it with a 4. 2x to the third becomes 2 times 4 to the third, which is 2 times 64, which is 4 times 4 times 4. So 4 times 4 is 16, times 4 is 64, in case anybody wants to know where I got that. 128. 2 times negative 5 to the third. Negative 5 times negative 5 is positive 25, times negative 5 is negative 125. So that's going to give me negative 250. Here I'm replacing it with a w. Then I'm going to multiply it by a 3 and add 2 to it. Well, 2 times 3 is 6.
So wouldn't the W be in parentheses?
No, because see how this x is not in parentheses? So then the w, we just took the x out and put the w in. We put the number in parentheses because I have to multiply it. But if it's just a letter, it's x and w. In this case, they kind of are the same. I can't multiply it or do anything to it, so I just put it there. Does that make sense? And then 3 times 2 is 6, and then I'm just adding 2 on the end. Here, I replace it with a negative 3 and a 1, and I'm subtracting them. So that gives me 2 times negative 27 minus 2 times 1, which is negative 54 minus 2, which is negative 56. We've been talking about determining the domain and the range when I give you like a set of ordered pairs or like a scenario. Well, now we have the domain and range from a graph. Okay, remembering that the domain is the x's and the range is the y's. Now, we have a set piece of graph here. It's like just a piece of a curve or a piece of a line. Now, when we have an open circle, we use less than. When we have a closed circle or a piece of the line, we use less than or equal to. And that'll make sense in a second. All right? What we're going to do is for the domain, we're going to have x because the domain is x. So we come over here, we find out this is the x-axis, this is the y-axis. So we're going to look and say, okay, what is the first x we would run into is right here. Do you guys see that? Yeah. Right here. So I go 1, 2, 3. This is negative 3. Okay. And then I keep going, and this is the last x I run into is right here. 1, 2. Positive 2. Okay. This is an open circle, so I do negative 3 less than. This is a closed circle, so I have less than or equal to 2. So this is telling me that the domain, the x's run between negative 3 and 2, but they don't actually include negative 3 because it's an open circle. For the range is y. I come starting from the bottom because that's my smallest. So I start from the bottom. So for x, I start this way. For y, I go this way. Here's my smallest y. So I have 1, 2, 3, 4. That's negative 4. Here's my biggest y. So that's 1, 2, 3. Positive 3. So I have negative 4. It's an open circle. This is a closed circle. Positive 3. So I'm going to write my x down. And my x's, you go this way. Y's, we start at the bottom and go up. Okay, so x, we're going to come across here. Here's my smallest x. So 1, 2, 3. That's negative 3. And then my last x comes here. 1, 2, 3. That's positive 3. Closed circle. So I have negative 3. Closed circle. X. Open circle 3. Bless you. For my range, which is y. So basically all you're doing is you're finding the borders of the picture. Like if I were to continue this across, I'd basically be drawing a box around it. Do you see that? So I'm looking for the borders of the box that would go around the picture. So on these, we're taking the function that's been solved and we're going backwards to find out what is n. Okay, so the total cost, we're going to take c of n and we're going to replace it with 380. So if c of n is equal to 60n plus 80, that means 380 is equal to 60n plus 80. We're going to solve, yeah.
So 300 to 60 plus 300.
We're going to divide by 60.
What?
To find out how much n equals, so 60n equals 300, so we divide by 60. So n would be 5.
Okay.
Got it? So it's but it's 1550, so I take c of n out and put 1550 in. Subtract the 5. So I get 1050 is equal to 0.50 n. Divide by 0.50. Feeling lazy? Don't feel like doing that in my head? 21 of them.